Okay, now let's do problem 8. Consider the vector u, which is 1, 1, 2, and v, which is 2, 1, negative 2. Okay, first, find a unit vector that is perpendicular to both u and v. All right, so just now we've discussed the cross product of two vectors is perpendicular to both of them. So we can just get the cross product. Right? To get the cross product for the first component, we temporarily remove the first components. Okay, then put the remaining parts together and calculate its determinant. For the second component, we put a negative sign in front and again temporarily remove the second components. Okay, temporarily remove the second components. And for the last component, we do the same thing. Okay, so this is going to be 1 times negative 2 minus 1 times 2, right? So it's negative 4. Okay. Here it's going to be negative negative 6, so it's 6. Here it's 1 minus 2, it's negative 1. Okay. Let's call this vector n, right? So you know n. But it's not enough. We also need to get the unit vector. The unit vector is n divided by its length, right? The unit vector is n divided by its length. So it's 1 over square root of negative 4 square plus 6 square plus negative 1 square. Okay. And times negative 4, 6, negative 1. Right, so the result is 1 over square root of 53, negative 4, 6, negative 1. Okay. In part 2, determine the scalar equation of the plane. All right, so we determine a scalar equation of a plane. That is through a point 1, 1, 0. Okay, it's through a point 1, 1, 0. And is parallel to u and v. Okay, it's parallel to u and v. So let's suppose this is u. Wait, so it's parallel to u and v. That means it's parallel to the plane generated by u and v. Okay, let's suppose this is u, this is v. Okay, then these two planes are parallel. So you want to know what is the scalar equation of this plane. Okay, this is your plane 2. Okay, what's the scalar equation? So, okay, part A, of course, it's going to be very useful because we already know a vector that is perpendicular to u and v, right? So we can draw that vector here. This is a vector. So because these two planes, they are parallel, right? So this vector is also perpendicular to the plane 2. Okay, now here's a trick. To get an equation of a plane, it's essentially saying that you want a way to verify whether an XYZ combination is on the plane or not. Okay, so here, now I just pick a random point on the plane. Okay, its coordinate is XYZ. I have a random point on the plane. And now I have a random vector on the plane as well, right? Because from this point 1, 1, 0 to the point XYZ, this is a random vector on the plane. Okay, and this vector is x minus 1, y minus 1, and z minus 0. Okay, this is a random vector. And this random vector is perpendicular to n hat. Okay, it's perpendicular to n hat. Or we don't even need n. Okay, let's do n hat. So it's perpendicular to n hat, which means the dot product, right? The dot product will be 0 because they are perpendicular. So a random vector on plane 2 is perpendicular to the normal vector. Okay, then you can solve it. So actually you can see this part doesn't matter. All right, it doesn't really matter. So it's negative 4 times x minus 1 plus 6 times y minus 1 plus negative 1 times z is equal to 0. Okay, so negative 4x plus 4 plus 6y minus 6 minus z is equal to 0. Okay, so negative 4x plus 6y minus z is equal to 2. Okay. Then find the distance between plane 2 and the plane containing origin and the parallel u and v. Okay, so what's the distance between these two planes? Okay, what's the distance between these two planes? Okay, to get the distance between two planes, you need two things, right? You need two things. First, you need two different random points on the plane. Okay, you need two different random points on the plane. For example, here, for this plane 2, you already know P, right? It's on the plane. This 1, 1, 0 is on the plane. Okay, and for the plane containing UV, okay, UV, they are not points. Okay, but you see the origin is on the plane, right? The origin is on that plane. So we have another point O, which is the origin, 0, 0, 0. Okay, so you need two random points on, right? You need a random point on each plane, and then you also need to know the normal vector. Okay, and then you also need to know the normal vector that is perpendicular to both. Okay, and finally, you can write down the distance. Okay, it's going to be the vector connecting these two random points, dot product, the unit vector, the unit to normal vector. Okay, and because sometimes the dot product, right, the dot product could be positive, could be negative. But here we put an absolute value. We take the absolute value of the result. Okay, this is not modulus. This is not anything. So, yes, this is modulus. This is not any vector related stuff. This is just the absolute value of something. Okay, so here OP is P minus O, right? It's 1, 1, 0. Dot product 1 over square root of 53, negative 4, 6, negative 1. Okay, take the absolute value. So it's 1 over square root of 53 times 1 times negative 4 plus 1 times 6 plus 0. Okay, so it's 2 over square root of 53.